I'm Sam Curtin. I'm involved in DIDCOM and the AIRS community and a variety of other things. But I'm happy to calling the Master of Ceremonies makes it sound all sorts of official today. But we do have a fine crew for our discussion. This is a little bit loosely based around things that happened at IW, but the main topic, of course, is OpenID and DIDCOM together. We have three folks that we'll be hearing from today. The first is Steve McCowan, who is a partner of crime of mine in the DIDCOM spec working group at the DIF. And he works for Anonymy. We'll then hear a little bit from Colton Wilkins, who will be doing a little bit of a demo, in-browser demo, if you're unfamiliar with that demo of DIDCOM. That's something you can play with today immediately, and also a really cool IoT integration. And then the main topic that will, if you don't know anything about DIDCOM, that's okay. We'll bring you along for the ride and introduce some topics. And then Arthur Phillip will be our last presenter, who will talk about the most excellent work that ID Union's done to bring together the OpenID and DIDCOM protocols. And so that's the general order that we'll go in. Feel free at any time to ask questions in the chat, and I'll be on top of those, and we'll have a few minutes at the end where we can answer questions of any topic. So I'm glad that you're here with us, and whether you're here live or viewing the recording. And so with that, Steve McCowan is going to talk about the basics of DIDCOM and sort of set the stage for the further discussions that we'll have today. Steve, it's the floor, as it were, is yours.
All right. Well, thank you for the kind intro. And let me go ahead and share some slides here. And I've got a new version of Zoom that works different. So hopefully, does this look good?
It does. Great. Looks great, especially the Powered by DIDCOM logo.
Yes, this is our new logo and our new marketing push to offer solutions powered by DIDCOM. As Sam mentioned, my name is Steve McCowan, and I'm a chief architect at Anonymy Labs. I'm Sam's co-chair at the DIDCOM working group, and I'm also a member of the steering committee. And down there at the bottom is some contact information, should you like to reach out after the meeting, not during the meeting, of course, because you're paying close attention. All right, so let's start. So this particular presentation is an intro to DIDCOM and what it means. And then the other presenters are going to take that down into some further detail. My job here is to kind of give you the intro and kind of set the stage for that. So what is DID communication? So in a nutshell, it's secure private peer-to-peer messaging. And from there, we're going to build on out. Verifiable credentials are shared about subjects, whereas DIDCOM is communication with a subject. And the two are very related. You can set DIDCOM credentials, or excuse me, verifiable credentials over DIDCOM, and exchange those, prove those, do all the things you need with verifiable credentials. So they're different, but very related. All right, so how DIDCOM messaging is set up. So the first thing we do is two or actually more players, but that's more of an advanced topic, will exchange DIDs. And that can happen in person via QR code. It can happen via a reference to a ledger or blockchain, or any one of a number of shared secured data resources like that. And what you're sharing initially is DID doc info. So this should be, decentralized identity 101. And that's exactly where we start. And in the DID doc, what you're going to find is a couple of things. There's an identifier for your DID, obviously, and a type field stating that you support DIDCOM messaging. And very important that we see in here are the service endpoints. So when exchanging DIDs, one of the things that you're exchanging is the identity of the other person, but also how you go about communicating with them. And so they'll have a URI where they can receive messages in the DIDCOM format. and what types of messages that they will accept. Now, you can do this direct peer-to-peer, one single hop, or you can do a variety of routing through mediators. Kind of looks like Tor if you want to build it out like that. And so there's a wide range of flexibility that we offer. Messaging flow, key point is it's asynchronous, so that you can be sending one message, 100 messages, and then the other party can pick those up, just like they would kind of email in a way, and read those and process those messages as needed. And sending messages like that is kind of dependent upon the protocol on top of DIDCOM. Now, some of the properties that we provide, number one, it's secure. So things are encrypted with strong encryption. We're using elliptic curve cryptography right now, and we had a discussion recently about moving to post-quantum cryptography. So while that's not in there yet, it's coming very quickly for all of us in the industry. And so that will be a part of DIDCOM at some point. And we're having discussions on how to do that. It's private. So with all this routing and DIDs and sharing of identifiers and different keys, we bring a very strong degree of privacy into this. So if there's people out on network sniffers, ISPs, enterprises, whatever, the airport, we will help you mask all those communications in a way that it increases your privacy. One of the things that attracted me to DIDCOM at the beginning was its interoperability. We see a lot of messaging protocols that are, they're kind of sandboxed. And so everything's strong within that environment, and everybody has to adopt that app in order to communicate. And what we're pushing here is that even if you have different apps that do different things, but they're compatible with the DIDCOM protocol, then you can operate and exchange messages back and forth. And that's something that's very novel in the industry, having strong encryption and privacy, but then also being able to interoperate in and out of your own sandbox, which is very cool. We're transport agnostic, so if you want to use TCP sockets, you want to use WebSockets, you want to use Bluetooth, NFC, put your DIDCOM message in an email address, or even strap it to a carrier pigeon, that is supported in the protocol because we don't rely on security or particular features of the underlying transport other than to get your message across. We'll talk about some extensibility later, and then I mentioned how things are very routable through mediators and so forth. Real quick, we're not going to get into too much detail here, but this is what a basic message looks like. You put it together in JSON, and you have some simple fields, an identifier for the message exchange, the type of message that it is, which will allude to the format of the particular fields, language, sent time, and then a body of your content, which can pretty much have anything that can fit in a JSON message. Agent messages get a little more complicated. They add a few more fields. So there's a from and a to. You might have an expires time because this is a limited time offer depending on your use case. And then that message, whatever you put down in the message body, can be dependent upon the higher level protocol you're operating under. And then we pack that message. Pack is a way to take the information that you see there and encrypt it, exposing only necessary routing information for the recipient to be able to receive your message and then decrypt and decode it. Here's a different view. So in the top, we kind of talk about what goes in the different fields. You have some header information. You might need an vector to start the encryption process. Sorry, I'm getting tongue-tied. And then all that information is how it gets translated when it gets packed. It might be base 64 encoded. It might be strongly encrypted, depending on the field. One of the things that we've tried to do with DIDComm is we have in blue there, you see the what amounts to the overall DIDComm protocol, and it rides on top of transports and it resolves DIDs. After that, it can be used for a lot of things. We have basic messages, think simple chat, back and forth encrypted chat. We can issue credentials. We can present verifiable credential proofs, requests and responses. There's a whole wide range of things that can ride on top of DIDComm. And we haven't built that all out. We've built the ability for you to do that so that you can take DIDComm and add it into your application that you're working on and to use it to be able to communicate between the parts of your environment. And so that is left up to your imagination. We have some excellent examples here in a few minutes where we'll talk about different protocols, different use cases that you can use DIDComm. And so that should help you see that whatever you're working on today can benefit from this as an underlying security privacy protocol. Couple things I wanted to point out. Didcomm.org is a site where we have a collection of protocols created by the community. There are resources that describe DIDComm and how to use it. You can get a link to the specification. There's code libraries, and we're putting together what's called the DIDComm book, kind of in the same vein as the Rust book. And it will tell you how to use, who's using, different ways of implementing DIDComm. And then the libraries we provide are open source. They're contributed by the community, so we haven't written them all. There's a lot in Python and Java, Kotlin, Android, Rust. Rust is neat because it compiles into a callable C library, which means you can build foreign function interfaces on top of that and link it into Swift and all sorts of other languages, JavaScript, TypeScript, whatever it is you want to do is probably supported either through a Rust wrapper or some of the native libraries that have been created. So that's a good but quick intro to DIDComm. Do you have any questions that I could answer?
You can type in the chat or come off mute, folks. Either way is good. We're a Zoom call on purpose so that we can be more interactive.
All right. Well, my contact information is up front, and it will be wherever this recording is available. And so feel free to contact me or Sam afterwards, and we can work with you, get your questions answered. Anyway, thank you so much for listening to this quick overview, and I'll pass the time back to Sam and on to the other implementation presentations.
Thank you, Stephen. I appreciate the quick overview to orient folks that may be a little less familiar with the particulars, and that gives us a good foundation. Next up, if you're interested in learning more, Colton Wilkins is going to be showing a way that you can do that right now in your browser with some of the stuff that he will be showing to help you learn a little bit more about how DIDComm works, and with a cool demo at the end. So Colton, I'll pass it to you.
All right, can you see my screen just fine?
We can.
As mentioned, my name is Colton Wilkins. I work for Indicio as a senior software engineer, but I'm also a co-chair of the DIDComm users group. And let's just move on to the demo. So we mentioned the DIDComm demo. This demo is in your browser, hosted at demo.didcomm.org. And the neat thing about this demo, let me just full screen one of these windows real quick, is that here we have our unique identifier with keys, but like every single time excuse me if my refresh button will work. It resets up all of the stuff needed to communicate with DIDCOM, anything that's needed. So as soon as you open it up in your browser, everything's all ready to go. And Steve went ahead and mentioned different protocols with a different type earlier. We can see that in each of these messages, we have a sent or received. This is a log of the communication going back and forth. And this is before and after encryption. Well, specifically before, when we send it, it's before encryption. When we receive it, it's after encryption. But you can see that each of these messages, they all have a type. And we've got it highlighted so that it's just like in the slide presentation that Steve showed off. We also have who the message was from and who the message is to. And the type here determines what kind of content you'll have in a body. And so here we have routing did information, and we have recipient update response, updated information, et cetera, et cetera. And you can also down here enter in custom messages, but we'll get to that a bit later. So with this demo, I've got it open in two different browsers here. This can be on the same computer. This can be on completely different computers. This could be halfway across the world. And what you can do here is if I have Dave and Zoe. If I press this button to copy Dave's did into my clipboard, I can go over to Zoe and I can say, I want to add a new contact. I want to talk to somebody new. So we will paste in Dave's did here. And this is more of a demo, like engineering type of demo for you to see. This isn't like a end user kind of demo. So a lot of the nitty gritty details are exposed here per se. So if I save this new contact with the did that I copied from Dave, you'll notice a couple of things as soon as I hit save. One, we will have a new entry on Zoe's screen under contacts, but we'll also have that entry under Dave's. So if I hit save there, we can see that Dave now knows about Zoe and Zoe now knows about Dave. The reason why why they know about each other is if I go into Dave on Zoe's screen, and I'll just full screen this again, we can see different arrows here indicate whether it was sent. So in this case, the message was sent from Zoe, and this message right here was received by Zoe, sent by Dave. And we can see that the first message we send is, hey, my name is Zoe. Could you tell me your name? Could you also tell me what kind of these different protocols? We talked about this earlier, the type, what different protocol types you support. And then Dave responds back with, hey, my name is Dave, and here's the list of protocols that I support. For each of these protocols, they are actually URLs that you can click on and view more information about what that protocol is. And if I open up Zoe here, or even if I don't open up Zoe, I can say, hello, Dave, and send a message. And on Dave's end, we take a look at what Zoe sent us, and we see that Zoe sent us hello, Dave. And I can send a ping back and forth. And I can also, one of the beautiful things about DIDCOM is we have this WebSocket connected right here. And that allows us to receive messages in real time. If I disconnect that, and then Dave responds back with, hello, Zoe. Are you there? Why are you ignoring me? And this might be the same case as if, Zoe went into, Zoe had a phone, their agent was on their phone, and they went into the mountains where there's no cell service. And so as soon as they come back online or come back into an area with cell service, the WebSocket will go from disconnected here to connected. And we can see that we now have messages saying, hello, Zoe, are you there? Why are you ignoring me? I wasn't. I was in the mountains. And Dave was able to receive that message. So that is a benefit of using the mediator, the relay, the routing that Steve had mentioned earlier. And you can see that there is persistence in messages when we go offline, and we can send different messages back and forth. Another demo that I would like to show off today. Let me bring in this Sybil client here. What I have with me is I have this Raspberry Pi device. It has a multicolor e-ink display. And I also happen to have a DIDCOM application running on this. If I were to take the, let me grab the DID real quick. So I've got it already pre-copied into my clipboard right now. And if I add the DID as a new contact, paste that in here, we can see that we now have a new contact, Colton's Raspberry Pi Zero. This happens to be running on a Raspberry Pi Zero. It is not connected to my computer whatsoever. It is just connected over Wi-Fi. The demo, when we mentioned IIW earlier, I showed off this demo, and the Raspberry Pi was connected to my phone. My laptop was connected to the conference Wi-Fi, and I was still able to perform the demo. So what I'm going to do is I'm going to go into the Colton's Raspberry Pi Zero. And we can see that we sent our name Sybil, and I don't have it programmed to respond to the features request here. But I do have a special protocol just for this little device, and that is name tag. Right here we can see it's got its own protocol type. And this is the custom messages that I was talking about earlier, where you can send back and forth custom messages. And so, if I enter in, my name here, Colton Wilkins, and I hit send, a few things will happen. We'll get a message coming back saying, setting the name tag, right here is the status, setting the name tag to Colton Wilkins, and the status is pending. And we see that the screen is cleared, and now it's blinking back and forth as it is changing the name tag. And in a few moments, you'll see that the name that shows up on here, it says, hello, my name is Colton Wilkins. And there's the yellow color there. But this also works bidirectionally. So you saw me sending a message to this and it was responding, but I also have a little button on the side here. And if I push that button like so, or did I have it disabled? Okay, I must have tinkered with the code there a bit, but it is you can see the status messages going back and forth anyways. The button was supposed to send a message directly from the Raspberry Pi to my browser here. But in my testing and experimentation, I messed that up. But again, you can see the messages going back and forth, and it even sent a status message or two status messages in a row rather than just one status message and waiting for a response back. So both of these came from the Raspberry Pi sequentially. Does anyone have any questions at this point?
There's been some good questions in the chat that we got to while you were delivering, Colton.
Okay. There are a couple of last things that I would like to notice, or make mention of. the code running on the Raspberry Pi and the code running in my browser. The browser, as you can see this GitHub link, the source code is all open source here. The DIDCOM demo is actually hosted on GitHub pages built from this repository. And I also have the code for the Raspberry Pi project here on GitHub as well. And while all this looks complex or may look complex to send a message back and forth and whatnot, the truth of the matter is, to get started with DIDCOM, we have a quick start library which can be utilized, and I shorten this code down as much as possible for a minimal example. And even with this message here being expanded out, you can send and receive messages through DIDCOM in 25 lines of Python code. Doing that in a lot of other protocols, I'd be hard pressed to see a bunch of bidirectional interaction in such a small space. And I'll post the links here in chat.
Very cool, Colton. Colton's done a lot of work to both have some cool demos, but also some the code that's available in the quick start code in the library is pretty awesome too. So very cool. Excellent. So hopefully that gives you a little bit of a background there. The next topic and our headliner, of course, that you're probably all eagerly awaiting is the ID Union work with making OpenID and DIDCOM work together. And so Philip is here or Artur, sorry, is here Artur Philip, I'm crossing my names, is here to talk about that. And he will both give the background and then the demo of what happened. I had the pleasure of representing at IIW, but you have the real thing here today, no imposters required. So I'll pass it over to you, Artur.
Yeah, thanks a lot, Sam. Yeah, I was not on the last IIW, so shame on me. So a few words about myself. I'm working for a company called SVA, Systemvertrieb Alexander, in Germany. And yeah, we are a system integrator and consulting company with different kinds of clients from the public sector, retail, healthcare, and so on. And we also focus on the topic of digital identity. And I did not prepare any kind of slides, but I will try to share my screen. Give me 1 second. Yeah, or maybe let's tell a story how all the stuff with OpenID DIDCOM, what we call this working group, started. So basically, I'm also involved in a project called ID Union, and I don't know if everybody of you knows or is familiar with ID Union. It's one of 4 larger research projects in Germany. It started around 3 years ago. And within ID Union, which consists of a lot of companies, so we have 15 core members of the project and a lot of associated members. When we started the project, everything was built on something that is called Hyperledger Indy. Maybe some of you heard about that. And Hyperledger Indy, basically, it's a decentralized ledger technology. So it's some kind of blockchain. We were using the Aries Cloud Agent Python. So for DIDCOM interaction, as it was shown by Colton and Steve. And we used a special credential format called AnonCreds. And that's how we start with an ID Union. So prototypes, use cases, even some of productive use cases were built on that tech stack. And within that tech stack, we use DIDCOM as set for messaging. But within Europe, from a regulation point of view, a lot of stuff already started going to happen. And we got something, a regulation which is called eIDAS 2.0. And with that regulation, it specified how the matter or the topic of digital identity is going to be handled within Europe the next years. And from this regulation, there's something reference called the Architecture Reference Framework. And that's some kind of, let's say, technical outline how the member states of the European Union should implement dealing with digital identities, with a verified credential, with wallets on their smartphones in the future. And what was written there in the architecture reference framework is that for so-called type 1 credentials or personal identifiable data credentials, you're prescribed to use something else than Hyperledger Indy. Basically, it's called OpenID for VC and OpenID for VP. And that's a different kind of protocol where you are not able to do the messaging like it was shown by Colton or introduced by Steve. What you could do very well with OpenID for VC and VP is you can issue a credential from, let's say, Dave to Zoe, and Zoe is then able to present a credential to somebody else by using these kind of protocols. But at the end in ID Union, we were asking ourselves, well, we start with Hyperledger Indy, we start with DITCOM, we are using Aries Cloud Agent Python, we have some use cases, and now we have to adapt to the new regulation called IDAS 2.0 and the architecture reference framework. But how can we recreate our use cases using OpenID for VC and OpenID for VP when there's no further communication besides the issuance of a credential and the presentation of a credential? And that's how the whole story of what we call OpenIDITCOM started. We tried to figure out how can we establish a DITCOM channel between communicating parties when they're in the flow of OpenID for VC for credential issuance or OpenID for VP, so the credential presentation. And now let's share the screen for a few seconds. Should be this one. And I hope you see some kind of sequence diagram.
We do see it, Artur.
Perfect. So basically, that's one sequence diagram out of the OpenID for verifiable credential issuance specification, which is available online. And I don't want to go too much into detail, but I would like to explain where and how we intended to establish a DITCOM channel, because that's what I'm going to show in the demo in a few seconds. So basically what happens in OpenID for VC is somebody, either the end user or the credential issuer, initiates the communication with the wallet. Then the wallet has to fetch some kind of metadata from the issuer. And there you can find, for example, how you can get the credential from the endpoint from the issuer, what requirements are given in order to get a credential, and so on. And the next step is that the wallet or the end user has to send an authorization request to the credential issuer with all the data that's required in order to get a credential. And the next most important part for us is here, the end user has to authenticate him or herself to the credential issuer. And basically that's what we are using within our working group, because that's something, it depends on the use case, how the end user authenticates towards the credential issuer. So basically here we can do whatever we need in order to establish a DITCOM channel. And after we did whatever we had to do, the normal flow continues, which basically means after authorization, you get something called an authorization response code to the wallet. The wallet can then use this code, again, send it to the credential issuer, and the issuer knows, well, okay, that's a valid code. Now I can issue an access token, which allows or gives permission to the wallet to fetch the credential. And then the wallet uses this access token, sends it to the credential issuer, and in exchange gets a credential from the credential issuer. And again, I would like to emphasize, so the idea is how and where in this flow can we establish a DITCOM channel besides or while we're in the OpenID for VC flow. So that's the flow when a credential gets issued. And as I already said, right here, because here in the spec, it's not defined, or it's very open how you authenticate an end user. And before I show the demo, we try to consider different scenarios for establishing a DITCOM channel. So one scenario, or one higher goal, was never touch the OpenID for VC spec. So we are also working very closely with the guys who are working on that spec, so that whatever we do, we do not interfere with the OpenID for VC spec. And we have the scenarios in which yeah, the obvious one is that there is no DITCOM channel at all required by the credential issuer. The second one is that the credential issuer offers the establishment of a DITCOM channel to the end user or the wallet. And the third scenario is that the credential issuer can even enforce a DITCOM channel. So in scenarios where you would like to have a established DITCOM channel in order to be able to send messages back and forward, that's the third variant here. And that, I guess it allows interesting scenarios so that the end user of the wallet can prove to the issuer, well, when you contact me on this DIT, you have a connection, you can always reach out to me using this DIT. And that's proven to the issuer, and then issuer knows, well, okay, now I can issue the credential to you. So let's show the demo, and I have to switch the screen. Where is it here? So, and I hope you can see my VS Code open now. So we are at the very beginning with the demo, but it's already working. Yeah, and when we reuse the roles that Colton presented, and they were named Dave and Zoe. So on the left, we have a terminal for Dave. In this case, Dave is the credential issuer. And on the right, we have Zoe, which in this case is the client or the holder. So Dave wants to issue credential to Zoe, and Zoe wants to have the credential get issued by Dave. So when we start, and hopefully it does start, the issuer, we have an instance running of the issuer. For this demo, we're using also a DIT web, which is stored on the GitHub repository of our project. I can share the link later. It's also an open repo. And on the right side, we start the client for Zoe, which wants to get a credential from Dave. Perfect. So now what happens? So we are more or less in the OpenID for VC flow, so not DITCOM, no DITCOM at all. And in OpenID for VC, we need something which is called an offering or an offer. And we can create this on our issuer side. So the issuer creates an offer, which then can be used by Zoe. So basically, this offer, this string contains all the relevant information that Zoe needs in order to fetch a credential via OpenID for VC from Dave. And let's paste it here. And when I confirm, a lot of stuff happens. So let's go through this slowly. So that's the offer you just saw. We are in something that's called pre-authorization code flow. That's a specific variant of OpenID for VC. And at the beginning, before a wallet requests a credential from the issuer, it has to contact the issuer and fetch the issuer's metadata. So here you see, okay, the holder, the wallet, so his wallet is requesting metadata from the issuer, from Dave. And what we did, we added one attribute in the metadata which says DITCOM required. So in this case, I introduced the 3 scenarios earlier. It's a scenario where we need to establish a DITCOM channel first in order to get our credential. So what we do is we request the token, the access token from the issuer. We get the token, and in a field which is called scope, besides the type of credential we would like to have, which is called university degree credential, we also add DITCOM, which basically says we are also intending to establish a DITCOM channel. And then, as was shown by Steve and Colton, we can create a very simple DITCOM message from Zoe, the holder, and send it to the issuer. What is not shown here is that not only does the metadata contain the attribute that DITCOM is required, it also contains the DIT address of the issuer. So the holder knows where to send this DITCOM message. And within the DITCOM message, we add the token, which contains the scope DITCOM, pass it over to the issuer. The issuer confirms. So we have an established DITCOM channel. And then afterwards, OpenID for VC continues as nothing happened. Like it didn't matter that we established the DITCOM channel, but we did, by the way. And then since I now have a DITCOM channel established, well, okay, that went well. Give me 1 second. Yeah, sorry for that.
There's a small glitch in the demo. When you get to that point, you can just hit the up arrow key, and
Yeah.
it'll get you back to the menu.
So okay, now it should be good, I guess. Yeah, and as you can see, the DITCOM channel established. So from Isha point of view, I can text to Zoe, to the holder, and vice versa. And basically, that's it. But I think it opens a bunch of new use cases, because in OpenID for VC, although it's very good in what it's intended to do, basically issue credential and present a credential, we lack the capability of doing further communication, the basic messaging that was introduced by Steve and Colton. For example, you could inform the holder that your credential is going to be revoked for any reason. Contact me and you will get a new one. And yeah, there are lots of other use cases you can think about. Basically, there is no limit. And that's the reason why we believe it makes a lot of sense to establish a DITCOM channel when issuing credentials or presenting credentials OpenID for VC, also because of interoperability perspective.
That's real awesome. Would you mind, Artur, pulling up the README file in the repo to show the differences? There's only a few differences that are actually made to an OpenID interaction, and I'd love to highlight those.
Yeah, sure. Give me 1 second. There we go.
And Jorge, I see your question. I'll get to there in a second.
So what exactly do you want to see?
So keep scrolling down. It's the green stuff, right? Oh, right there, up a little bit.
Yeah.
So this shows the interaction there, and there's really only the three changes that are actually made into the OpenID flow. So there's the DIDCOM did that's in the issuer metadata, and Artur referenced this earlier, and then also an indication about whether a DIDCOM connection will be required or not as part of the flow. And that's just in the issuer metadata, and it doesn't change the existing values, it's just additional. And then the only other thing is that down in the actual scope specified, a little bit further down the page, you include, along with the name of the credential that you're seeking to either get issued or present, the DIDCOM scope is indicated, and that's it from the OpenID side. And then the rest is a DIDCOM protocol that actually does the exchange to make that happen. So this is really minimal. It's a really great solution. The other thing I'll mention about the demo is that it's running on localhost, so it looks like it's faked. It's totally not faked, in the sense that the OpenID interaction that's happening is a real OpenID interaction, and the DIDCOM interaction that's happening is really using encrypted messages back and forth behind it. And so there is no besides the fact that it's running two instances on the same computer, obviously for demo purposes, there is no like pay no attention to the man behind the curtain. It's actually really happening through there. So Jorge, you asked if a DIDCOM connection is established as a first step between Zoe and Dave, could Dave then share an OpenID for a VC credential over a DIDCOM message? The answer is yes, although we haven't quite defined that yet. But in the OpenID protocol, you pass an invitation, and that was actually in the demo, and Artur copied it from one and pasted it to another one. The OpenID for VCI protocol does not actually does not specify how an invitation is to be passed, but there will be a protocol designed for passing that an OpenID invitation between two parties that happen to already have one. And so this is useful. For example, if you were to use this process that Artur showed, then you could issue a credential over OpenID. You end up with a DIDComm connection. If you wanted to issue a subsequent credential, you could actually just use a DIDComm message to bootstrap that process of sharing that along. And so that's definitely coming. It hasn't been documented yet, but mostly just because we're focused on getting the previous work ready for IW. So it'll be along shortly.
Maybe one thing to add here, which is cool, I guess, you don't have to reuse the DID. You could technically create always a new DID when you request a new DIDComm channel in order to avoid any kind of correlation here as well. And I think from a privacy perspective, that's also good to do it this way.
Yeah, and that choice is left up to the wallet. So the wallet can decide
Exactly.
if they want to reuse the DID or not. And there's arguments for both use cases, right? So you get to decide what you want to do from a privacy perspective. Yeah, very good. And then Dave asked, is there a possibility of a DIDComm connection between more than two parties, for example, a group chat? So there is, but it's more complicated. We wanted to make sure with DIDComm that it was initially designed to serve its use case very, very clearly. And so you can share messages between more than one party, but at this point, they are all treated as point-to-point messages. So if three people are talking, every time one of the parties sends a message to the other two, they're going to send two independent messages out. There's some discussion underway about how to optimize that for larger group cases that need more coordination to make happen. And so that is coming along there. The other thing that I'll mention is that DIDComm by its nature works really well with the devices the humans use, right? I've got my phone here and I can't host an API on my phone, but I can receive DIDComm messages that are relayed through a mediator that doesn't get to see the encrypted message. And so that structure allows for API-like interactions in the sense that semantically rich data can pass back and forth, but in a way that favors the devices that humans use, like phones, laptops, tablets, those sorts of things that are not always connected and don't always have battery, right? They're not persistently on. So that's very cool. So you can then receive a verifiable credential over DIDComm or OID, right? Yes, you can. I'll also mention that nothing about the credential formats is stuck to the protocol that's actually been issued. So you can kind of mix it up any way you want. You can take a credential that's issued over DIDComm and present it over OpenID, or vice versa. And so that all works really, really well. Both of the protocols are designed in a protocol type agnostic way, which is really cool. Yes. Otto, is it worth banding together and defining a generic OpenID for VC profile that could support various DID methods that support DIDComm? This is a great work by the ID Union folks as a base. Yes, actually, that's been under discussion at the DIF, the Decentralized Identity Foundation, and so there very likely will be a sort of OpenID DIDComm profile that highlights some commonality so that implementers can use all of those together. And so that's definitely coming, Otto.
I would like to add on just in regards to the group chat. There has been discussion in the DIDComm users group about that. There are a bunch of different ways to accomplish group chat, whether that's peer-to-peer group chat or kind of like hub and spoke group chat that we're all used to today with services like Facebook Messenger, etc. Lots of possibilities there, and there's more to be explored in terms of what people will do.
Yes. So the other question Michael asked was, hey, you did OpenID for VCI. How about OpenID for VP? Yes, absolutely. We are hoping that the same strategy can be used because it is really lightweight on there in order to correlate the OpenID interactions with the DIDComm connection. But we want to make sure it hasn't been stamped yet. We want to make sure that it has that it works the way that we think it does, and there's no sort of weird consequences that we hadn't foreseen. So it's in a lot of review right now to make sure that we accomplish those things. But yes, absolutely with OpenID for VP, that's another really useful thing. These are awesome questions, actually. So any examples? Cross-product messaging. Yeah, the link that Colton shared is a project that he's thrown together. I don't know of other production peer group messaging. There may be some out there. There's lots of folks using DIDCOM that I discover every day that are doing new things, but I'm unaware of anyone doing that specifically. Can you come back on the DIDCOM channel creation and detail a bit more how it's working after the token response? Can you clarify the question, Raphael? What would you like to see?
Yes, thank you. I just am not sure to understand how the channel is created when you get the response, the token response, and just before the credential request.
Yeah, do you want to take that one, Artur? Or should I?
Yeah, sure. No, I can go. So basically, when you get the access token from the issuer, oh no, let's go one step back. No, you got the access token, and basically the access token is also your ticket for establishing the DIDCOM channel before you request the credentials. So you, as a holder, you just send a DIDCOM message to the issuer. You get, in order to do so, the DID from the issuer from the issuer's metadata, which you fetched earlier. So you know exactly where to send this first DIDCOM message. So you send a message, and the content basically is the token. So that was what meant by correlation. And the issuer then recognized the token, established the DIDCOM channel, and then you are done from the holder side. And then you can request the credential. And since the issuer knows or figures out, well, for this token, there already was a DIDCOM channel established. Now I can be sure in case when the DIDCOM is required, I can issue the credential. I hope this clarifies it a bit more. If not,
Yeah, so
please.
out of the same repo that Artur presented out of, there's a DIDCOM protocol inside of code. There's a markdown file here describing the protocol, and so this is just what Artur was saying. So there's an OID associate protocol that presents the token, and this is the one that you received as described. And then there's an acknowledgement that comes back that's a yes, and there's a no that can come back should that token be rejected for some reason. Perhaps it's too old or something else. You know, that and the reject is really primarily here for a good user experience. That way there's something proactive that the application can do to help the user through. So this is a very simple DIDCOM protocol, and just, you know, passing the token as Artur described. So this is what you would do during the DIDCOM exchange. Elsewhere in the documentation, it covers over this really fast. But this is the protocol, and this is actually the protocol being used in the demo. That it uses these messages in order to associate that connection. Yeah, does that help, Raphael?
Yes, thank you very much.
Absolutely. We have just a few minutes left. Any other questions? Is the DID document passed in the OpenID response or just the identifier? So the DID actually is passed in the issuer metadata, and that's what's used to initiate the connection with DIDCOM. The way that DIDCOM works is that when you receive a message from a party, it contains the sender's DID, and so you're able to then, of course, you know, both parties know both DIDs at that point. And so just the identifier is passed. The resolution of the DID to the DID document happens in whatever method is used for the selected DID method. There's nothing different about that. These are excellent questions. Any more before we close up today? And if we don't get to a question or you think of one later, please reach out. I'm Telegram Sam on all the things, and as well as Artur and Colton and Steve are also around and happy to answer questions about anything that happened there. So very cool. Before I pass it back to Helen, I'd like to just thank Steve and Colton and Artur for joining me today and demonstrating all the cool stuff that's happening. I hope this was informative, and that you learned a lot, and I appreciate you being here. And Helen, back to you.
Thank you. And I second everything you just said. Thank you so much for our speakers. Thank you to everyone who joined us. Our next meeting of the Indicio Identity Community Meetup will be the last Tuesday of the month in May. So that's May 28th. And where we will be hearing from somebody who is working on data around sports like and athletes in the NFL and using verifiable credentials for a business model around athletes and sports. So really exciting, very interesting stuff. If you want to hear more about the business side and the application and that sort of thing, it would be great to join that one. And then that's also the week, I think, before EIC, the European Identity and Cloud Conference. I know Indicio will have a crew there. So if you want to come and chat with us about preparing for that, we will be talking a little bit about what's going to unfold at EIC. So hope to see you there. We'll see you next month. Thank you, everybody.